All right, so now that we have vector addition and subtraction all defined and ready to go, let's look at an application. So we're going to revisit the airplane, and what we're asked to do is to find the velocity vector of the airplane traveling at 50 miles per hour on a bearing of 60 degrees with a tailwind, all right, I guess that a typo there, of 60 miles per hour on a bearing of south 45 degrees east. All right, so physically what's going on here, right, is the tailwind is actually going to get in the way or help the plane go faster or slower. So when I draw a picture of the situation that's going on here, right, we've got a plane, it's 60 degrees, right, from north, which means that it's 30 degrees, right, from due east or along our x-axis. And it's operating at 500 miles per hour. So there's basically a visualization of the airplane's velocity vector. And then we have a tailwind that's 60 miles per hour, south 45 degrees east. So we're going to go south and then 45 degrees east, right, which is 45 right there. Alrighty. And so there's basically the tailwind, right? That's basically at 60. So what I basically have here is I've got the shape of a parallelogram. Let me kind of point this out here. And essentially, the velocity vector we're looking for is what I just drew there. As a matter of fact, let me change colors to... All right, so the velocity vector is this vector right there. All right, and it's basically, if I can find the velocity vector of the airplane, add that to the velocity vector of the wind, right, that's basically the velocity vector in total that we're looking for. So that's the velocity vector that we're basically after. All right, so basically you can see an application of our addition information. And of course, what's going on here, you can kind of see that because of the way the directions are and everything, the plane is actually losing some placement, if you would, in the y direction, but it's gaining some placement in the x direction. So the wind is kind of pushing it along, right, in the x direction, but it's kind of in its way in the y direction. But we do end up having a vector that looks physically longer than the 500, right? So it is pushing us along and helping us. So how do we find that vector? Well, earlier in our work, right, we found that the velocity vector of the airplane was 500, right? The cosine of 30 degrees, the sine of 30 degrees, right? And after a little bit of work and finding some exact values, right, we found this to be 250 square roots of 3 and 250, right? So that was basically the velocity of the airplane. And then we also found the velocity of the wind, right? That was 60. And again, we're talking about a 315 degree, right? Cosine of 315 degrees, sine of 315 degrees. And of course, what we found there is that this is 30 square roots of 2 and negative 30 square roots of 2. So there's basically our velocity vector for each one. What we're looking for is the one that basically combines them. So if I add these two vectors up, right, vector A plus vector W, right, all I have to do is add up their x components and add up their y components. So we end up with the vector 250 square roots of 3 plus 30 square roots of 2 and 250 minus 30 square roots of 2. So there is the velocity vector, all right, of our airplane with the tailwind kind of pushing it along. All right, so we've done that part. We found the velocity vector. The next phase is they want us to find exactly how fast the airplane is traveling. So that is basically the magnitude of the vector that we just found. All right, so let me move this up a little bit so I don't lose you guys. All right, so the way we calculate that, right, we've learned that to find the magnitude of the vector, right, we just basically take my x coordinate, So 250 square roots of 3 plus 30 square roots of 2, and we square it. Take my y-coordinate, 250 minus 30 square roots of 2, square it, and then we take its square root, right? So that's what we found through our definitions. So this is basically your exact value, all right? If I didn't have you guys have a calculator in your hand, but for all intensive purposes, let's go ahead and turn to our calculator. Again, I'm using Desmos just to save a little bit of time on the video. I've actually downloaded this stuff into Desmos. Let me just finish punching some numbers here. Okay, and what I end up getting when you perform this operation in Desmos, we get 518.776 miles per hour. Or if you want to really round it off, the plane's traveling about 519 miles per hour. So you can see that the plane is in fact being pushed by the tailwind. The plane itself, ground speed is 500, but because of this little tailwind, it's pushing it along, and the plane's actually experiencing a faster speed at 519 miles per hour. So that is part B. So we got A and we got part B. What about the bearing of the airplane, right? What's the angle right there that the airplane is on, right? And again, the angle we're going to find is the angle is going to be along the positive x-axis. For bearing, right, we have to do some other items. But what we know, let me scoot this up a little higher again. All right, so from previous work, we know that the angle I'm looking for, right, the tangent of that angle is my y-coordinate, 250 minus 30 square roots of 2, right, divided by my x-coordinate, 250 square roots of 3 plus 30 square roots of 2, right? And so when we put this together, right, we're going to basically our theta is the inverse tangent of that fraction. And so let me cut to the chase. What you end up here is 23.5858 degrees. All right, so again, let me bring the picture down here. That is right there, right? That's the 23.585 degrees. What I want is the bearing. So to find the bearing, right, I'll basically take 90 minus 23.585, and doing some number crunching over here, that comes out to 4142. 4142 degrees. So in sum, right, what we have, right, in terms of a bearing, let me scroll this down so we can put this all in summary, right? After all that work, what I have is that my plane is traveling at 519 miles per hour, right? Make sure I scroll down a little bit more to make sure you guys see that, right? And it's going at a bearing of 66.4142 degrees. And because we're in the first quadrant, we can even say that it's going north 66.4142 degrees east. All right, and that answers part C about what the bearing of the plane is. Okay, and of course, if I wanted to stay on course, right, we would actually point the plane in another direction so that with the tailwind, right, I'm back on the course that I'm at. Or we just basically have, want to go in that direction and we'll change course later on, right? But that gives you a nice application of vector addition, right, with regard to velocity, right, and adding velocities and getting what we call the resultant again, right, the resultant velocity. I guess I should have said that earlier. Okay, so that wraps up addition and subtraction, right? We're going to move on to multiplication, but that'll happen in some videos coming soon. Talk to you later.